Hello guys, this is Neha. Welcome to my channel Guruaura. Today we are going to talk about Cartesian product from the chapter Relation and Functions. Let's understand what is Cartesian product of sets using an example. As in our previous videos, we studied about sets. A set is a collection of well-defined objects. So let's consider two sets. Set M, the set of musicians, the set I, the set of musical instruments. The elements of set M are Joe and Matt, and the elements of set I are guitar, violin and tabla. Now, let's see all possible ways in which every musician plays every instrument. Let's have a look on the arrow diagram. Here, the set of musicians is on the left and the set of instruments is on the right. Now, the white arrows links musician Joe to all the three instruments, which depicts that the musician Joe can play all the instruments. Similarly, the red arrows links musician Matt to all the three instruments. That also means that the musician Matt can play all the instruments. So, here we are drawing an arrow diagram from every musician to every instrument. So now let's write down all possible ways in which each musician play each instrument. Here we have these 6 combinations. Now let's closely look at Joe, guitar. Here the first is musician Joe and the second is the instrument. And both are enclosed within round brackets, separated by a comma. Now here a question arises. Why round bracket? We have learned to use curly bracket in our previous chapter sets. So dear students, this is because the order in which we write within the round bracket matters. Here, as the first entry is musician and the second entry is the instrument, that is guitar in this case, the relation between the two entries is musician Joe plays guitar. Now if we write guitar, Joe, it will mean that the guitar plays the musician Joe. Is this relation correct? Definitely no. So we cannot write guitar as the first entry and Joe as the second entry. So we can conclude that the order of element within the round bracket matters. Therefore, combination of musician, instrument is called an ordered pair. Ordered pair implies that the order matters and it is represented using round brackets. Now, if we consider Joe, guitar to be an element and we have similarly 6 elements. And if these elements are enclosed within curly brackets, we get a set. Let's name the set as M cross I. So the set M cross I encloses 6 elements. And M cross I is the Cartesian product of sets M and I. Thus, M cross I is a set with Joe, guitar as its first element, Joe, violin as its second element, Joe, tabla as its third element, and so on. Now let's write the Cartesian product of set M and I using the set builder notation. We write it as like this. M cross I is equal to curly bracket open followed by M, I in parenthesis such that lowercase m belongs to set M and lowercase I belongs to set I, curly bracket close. So now we are ready to define Cartesian product of two sets. Let A and B be any two non-empty sets, the set of all ordered pairs A, B such that A belongs to set A and B belongs to set B is called the Cartesian product of sets A and B, denoted by A cross B. Let's consider two sets A and B. The elements in set A are 1, 2 and 3, and the elements in set B are A, B. Now we get 6 ordered pairs, and when these 6 ordered pairs are written within curly brackets, we get a set. So A cross B is equal to curly bracket open 1 A, 1 B, 2 A, 2 B, 3 A and 3 B are the 6 elements. Clear? Now let's understand cardinality of Cartesian product of sets. What does cardinality of a set mean? Cardinality of a set gives us the number of elements in a set. Let's consider two sets, A and B. Set A has elements 2 and 3. Set B has elements 4, 5 and 6. What is the cardinality of sets A and B? The cardinality of set A is 2 and the cardinality of set B is 3. As there are 2 elements in set A, the cardinality of set A is 2, and as there are 3 elements in set B, the cardinality of set B is 3. Now we come to an important question. What is the cardinality of the resultant set? That is A cross B. It would be the number of elements in set formed after the Cartesian product. But is there any other easier way to find the cardinality of set A and B? Yes, there is. According to the property of cardinality of set A cross B is equal to the product of the cardinality of set A multiplied by the cardinality of set B. Here, the cardinality of set A is 2 and B is 3. So we can easily find the cardinality of set A cross B. The answer will be the product of 2 and 3, which is 6. Thus, generalized as if there are P elements in A and Q elements in B, then there will be PQ elements in A cross B. Before we wrap up, let me tell you one more thing. What happens to Cartesian product of two sets when one or both the sets have infinite elements? Let's consider a simple example. We have two sets A and B. A represents the set of even prime numbers and B represents the set of natural numbers. Set A contains only one element, 2, as 2 is the only even prime number, and set B contains infinite number of elements. Thus, we get a set of infinite ordered pairs. So what did we just see? We just saw when one or both sets have infinite elements, the Cartesian product has infinite elements. If either A or B is an infinite set, then A cross B is an infinite set. So, in this lesson we learnt about Cartesian product. In our next session, we'll see some interesting points on ordered pair and then work out some problems related to Cartesian product and ordered pair. Hit that like button if you like my videos and don't forget to subscribe and share. Thank you.